In section 7.3, we're studying logarithms. So the goal is here that we will be able to evaluate and simplify them. So let's start, just brief recall, and this is on the most basic level. When we solve this equation 2x equals 8, we solve it by dividing by 2, right? And we say, oh, x would be 4. Well, the reason why we divide by 2 is because those are like inverse operations, like they undo each other. And then on the most basic level, that's the idea of an inverse operation. And so I bring that up to ask you to try to solve this equation, 2 to the power of x equals 8. In this one, you would need to use inverse operations just like we did above. However, the x is in the exponent. So we would need to take the inverse to figure out what x would be here. The inverse of an exponent or exponentiation is called a logarithm. Logarithms, so this is like a definition of logarithms. The logarithm base b of x is defined as follows. Log base b of x equals y if and only if b to the power of y equals x. And we have some restrictions. B has to be bigger than 0, b cannot equal 1, and x has to be bigger than 0. Strictly bigger than 0, it does not say bigger than or equal to 0. So if x is equal to 0, we would get something undefined. The logarithmic function y equals log base bx is the inverse of the exponential function y equals b to the x. So in your example, it says the inverse, write the inverse of y equals 8 to the power of x. So the inverse there, we would want to use a logarithm because this is an exponent. So log, our base is 8. And if we just look above, so our base is 8. So the b goes down below here. The value taking the role of the x is y. And our exponent is x. So this would be log base 8 of y equals x. So let's go ahead and define this a little bit more clearly. Exponential form and logarithmic form. What a lot of your problems on your homework are going to ask you to do is convert from one form to the other. So exponential form shows that a base raised to an exponent equals the result. So if we stick with the notation we've been using, then we have b to the y equals x. That would be your exponential form. We would write this out, and just so we can see it, I'll write it, is base, which is b, to some exponent equals a result. So base to an exponent equals your result. Logarithmic form shows the log of the result with the given base equals the exponent. That says is log base b of x equals y. So another way to state this is log base result equals exponent. So these two functions are inverses of each other. Exponential function is an inverse of a logarithmic function and vice versa. Like a logarithm is an inverse of the exponential function. So to convert between logarithms and exponents, you need to identify 3 key pieces of information. It's the base, so 1 is the base, 2 is the exponent, and 3 is the result. So you need to identify each of these 3 things for each problem. I would put what's in this box on a note card and have it handy. I would pause the video, make sure you have this written down because that will help you on the next page. And just real quick before we flip on, let's go ahead and just for shorthand notation, let's call the base B, the exponent E, and the result R. That way we don't have to write down base, exponent, result each time. Just write BER. So now let's flip. So you always want to start, no matter what form you're given, you always want to start with identifying the B, the E, and the R. When it's given to, so example 2A, what is the logarithmic form of 3 to the 4th power equals 81? When it's given to you this form, it's pretty easy. 3 is your base, 4 is your exponent, and your result is 81. So now this is where you want to look at that note card or the sheet of paper where you jotted down what was in that previous box. So we said that if I want to go from a logarithm to an exponent, then I would use log base results equals exponent. So I'm going to write log. My base is 3. My result is 81. And my exponent is 4. So that says log base 3 of 81 equals 4. Which this means 3 to the 4th power is 81. Example B. What is the exponential form of log base 10 of 1000 equals 3? So you need to identify the B, the E, and the R. The base is this little subscript here. So the base here is a 10. The exponent, if we look back up here, the exponent is on the right of the equal sign. So the exponent here is 3, and the result in this case is 1000. So what we would write, then our exponential form would be base. Our exponential form is, remember, it's base to the exponent equals result. So base is 10, our exponent is 3, and our result is 1000. So that's a simple. Going back and forth is pretty easy. All you need, just identify your base, exponent, result, and then you can go from one form to the other. The interesting part is when you start evaluating these things. So I think this is best illustrated with an example. To evaluate the log base 5 of 125, you would want to think to yourself, 5 to what power gives me 125? And we'll use x because we don't know what that power is. So you could run through the list. 5 to the first power is 5. 5 to the second power is 25. And then 5 cubed, you would stop there and you'd say, okay, that's 125. So since 5 to the third power is 125, log base 5 of 125 equals 3. So 5, what this says is 5 cubed equals 125. So let's work out a couple more examples. So example 3A there, log base 3 of 27. So you could write the statement, think 3 to what power is 27? So obviously 3 to the first is 3. 3 squared is 9. 3 cubed is 27. So x would equal 27. So you could say log base 3 of 27 is, oops, x equals 3. Sorry about that. So x is 3. So log base 3 of 27 is 3. There is a sort of a shortcut we'll learn about a little bit later on, but for now we'll go this route. So we would say x is 3. So log base 3 of 27 is 3. Let's do the part B. So log base 2 of 16. So what you would want to think is 2 to some power of x is 16. Well, so you would run through your list, and if you ran through that list, so you would test 1, 2, 3, so those various values for x, and what you would find is that x equals 4. So 2 to the power of 4 gives you 16. So log base 2 of 16 is 4, because 2 to the 4th power gives you 16. Part C, log base 3 of 0. We had a restriction given earlier that said your result can't equal 0. So this one, you would say, we could say undefined, and we could say result cannot equal 0. Part D, log base 1/4 of 16. So this one's kind of interesting. So log base 1/4 of 16, I'll zoom in a little bit, whoops. So log base 1/4 of 16. So you would want to, what you're really asking yourself here is 1/4 to some power of x equals 16. What x gives you that? So let's think about this. 1/4 to the first power is 1/4. 1/4, so let's increase x by 1. 1/4 to the second power would be 1/16, which is smaller than 1/4. 1/4, then if we go increase the power of x to 3, then you would have 1/4 to the third power. Notice as x is getting larger, your value would be actually getting smaller, but we want this value to be getting larger. We really want this to say 16. So now you need to recall the properties of exponents, where we had this property that said 1/x to the m equals, it equals x to the negative m power. Can't see that. Zoom out a little bit. So it equals x to the negative m power. So in this case, 1/4 to the x, well, x to the negative m, so 4 to what power gives you 16? So you could ask yourself, 4 to what power is 16? That's 2. So 4 squared is 16, which means x would be -2, because we just have to take our exponent and make it negative. So this would mean log base 1/4 of 16 is -2. Zoom out a little bit more. So that would be your answer for this one. Log base 1/4 of 16 is -2. Please watch the next video for the remaining part of this section.